All right, good morning. This is Mr. Cornier. This is benchmark number 27. This is part B, example number 4. We're going to classify quadrilaterals using coordinate geometry. Again, the site that I'm gonna go to is the GeoGebra in a minute. But the question states, determine whether the parallelogram ABCD is a rhombus, a rectangle, or a square. And then the coordinates are A, -2, -1, B, -1, -3, or -1, 3, C, 3, 2, and D, 2, -2. And we want to list all that apply and we want to explain why. So again, I need to know those properties of a rhombus, a rectangle, or square. So I'll be back in a minute and I'll go ahead and graph this on GeoGebra. We are on GeoGebra. I went ahead and listed the points -2, -1, for A, B, -1, 3, C, 3, 2, and 2, -2. What I want to do here is going to move this over just a little bit, make this just a little bit larger. I'm going to go to my tools. I'm going to look for a polygon. I'm going to start on my vertex A. I'm going to make my way all the way around to D. All right. So now the first thing I want to do after plotting the points, I want to see if the segments are congruent. So let's, first thing I want to do here is going to go to my measurement. If I could find it, there it is, distance and or length. So there goes the distance, 4.123, 4.123, 4.123, and 4.123. So I know that all of the sides are congruent. All right, so the sides are good. So I know it's either a square, actually a rhombus. Let's see if the angles form 90 degrees. So I'm going to go to a measurement angle. It says select 3 points or 2 lines. I'm going to select 2 lines, 1, 2. There goes my 90 degrees there. Okay, I don't necessarily like how that's looking, so let me go 1 to 80. So 90 degrees there, and I'm going to try this last one here, and 90 degrees here. So I know all the angles are 90 degrees, so I know it's going to be a rectangle, but before I do that, I want to go ahead and construct a line or a segment from B to D, and from, let's see, what is that, A to C. I want to see the distance between A to C and B to D. If the distances are congruent, I know it's a rectangle. So let's go distance or length. Okay, I don't want that, so I'm going to go back. I want the perimeter I want. Okay, so the distance from A to C is 5.83. I'm going to do the same thing over here. And let me move some stuff around so I can see some of these numbers. 5.83, 5.83. So the distances for both the rectangle, the diagonals for the rectangles are congruent. The sides are congruent. I can safely say that it is a rectangle, it is a rhombus, and because it satisfies both of them, I know it's going to be a square. If you have any questions on this, please let me know. This last example, number 4 in benchmark 27B, again, ABCD is a rhombus. All the sides are the same. We know it's a rectangle. The diagonals were the same. Therefore, if it's a rhombus and a rectangle, it's going to be a square. So let me know what you think about this. Look over the notes. And again, just ask those questions. Get me involved in that learning process. All right, talk to you later. Bye. We're going to go ahead and finish up this lesson, benchmark 27B, with some coordinate geometry. We want to determine whether the parallelogram EFGH is a rhombus, a rectangle, or a square for the coordinate points E, F, G, and H. And you want to list all that will apply in this case. So again, my first step will graph this out on a coordinate plane or on that GeoGebra. In order to find out if it's a rhombus, make sure the sides are congruent. If it's a rectangle, you want to make sure that the diagonals are congruent. And if it's satisfied rhombus and rectangle, then it's going to be letter C. Or it's in the, the sides aren't the same, the diagonals aren't the same, so it's going to be none of these. Enjoy, take your time. No shortcuts, no guessing. Go in GeoGebra and work it out. All right, talk to you guys later. Bye.